Hello, good evening to all of you. Dear students, in this particular lecture, I am going to elaborate about lenses. What do you mean by lens? Lens is a transparent material bonded by two curved surfaces. Right? There are two types of lenses. One is your convex lens and other is your concave lens. Dear students, how to recognize a convex lens or a concave lens? How you can distinguish between convex lens and concave lens? Suppose both the lenses are in your hand and you try to recognize both these lenses by touching. Dear students, when you touch convex lens, you feel that it is thicker in the middle and thinner at the edge. Similarly, while recognizing concave lens, you feel that lens is thinner at the middle and thicker at the edge. Dear students, lens is made up of two spherical refracting surface. These two refracting surfaces are curved. Let us see. This is your one spherical refracting surface and this is your another spherical refracting surface. These two surfaces, this one is a P1 and Y, and this is again a P2 into Y. These are two spherical refracting surfaces, right? Their radii of curvature are same. These two curved surfaces are a part of a sphere. Let us draw. By completing the sphere, this one surface, this is the sphere. Okay, again this is the second sphere. Dear students, when you see, this is the C1, center of this particular part of the sphere, A P2Y, and this is A P1Y is the part of second sphere with center of curvature as C2. So this is C1 and this is C2. These two are center of curvature for one curved surface and this is for second curved surface. Let us introduce to you why the terminology associated with these two lenses. So, and this is your convex lens and again two curved surfaces, right? This one and this is this one. This is C1 and this is C2. Again A, P1 and Y and B, P2 and again it comes to be Y. This lens is very thin so that this point O is termed as center of lens, that is optical center. This particular point O is termed as optical center. Again this O is termed as optical center. Dear students, this particular distance from center to OP1 is known as radii of curvature, that is R1, and again from here to C2 this is equal to R2. This is the radii of curvature. Again dear students, in case of a concave lens, as I earlier mentioned that this concave lens is also bounded by two spherical curved surfaces. So by completing this sphere, C1 center of curvature and this is R1 radius of curvature and again this is radius of curvature. So these two particular lenses are concave and convex lens. Now what does this mean? How image formation take place in these two lenses? Let us have a few terminology associated with it. I will write one by one. That is, first is your aperture. What do you mean by aperture? Dear students, this refracting surface is a part of a sphere and again this refracting surface is again part of a sphere. Okay, A P1Y and A P2Y again. So dear students, this refracting part, this refracting area is termed as aperture. The refracting part, the area of refracting part of a sphere is termed as aperture. So aperture, this is your aperture. And again the second term which I want to explain is focus. What do you mean by focus? This is your optical center and a line which passes through optical center and pole is termed as principal axis. Is termed as principal axis. Dear students, when ray from infinity come and strike at this spherical refracting surface, or you can say that reflect from this particular lens, it passes through a point and this point is termed as focus of a lens. This distance particular from optical center is termed as focal length, denoted by small f. This is your focal length. Now we want to understand the basic concept behind this particular lens. So dear students, how refraction take place, I will explain by particular diagram how refraction take place in a convex lens. This is your convex lens, okay, and P1 by, again this is pole P2, A P2 by, okay. Now dear students, this lens has two spherical refracting surface. So we will learn here how refraction take place. Take this line, principal axis, and suppose this is the center of curvature for this surface, and again this is center of curvature for second surface. Suppose object is placed at this point. Now what happened? A ray travel from this particular point, and this particular ray is parallel to principal axis. Then how you can draw the ray diagram, we will learn here. You just draw normal at this particular point from center of curvature. Dear students, this medium is rarer medium and this medium is denser medium. Now what happens when a ray of light travel from rarer medium to denser medium? It went towards normal. The path of ray is like that in this particular optical denser medium. Again you draw normal from center of curvature. Then ray of light travel from denser medium to rarer medium. It went away from the normal. So you will see that this ray will bend towards this point, and this point, as you know, is focus. So this is the way the ray of light suffers two refraction, one at this point and one at this point. In your class, we generally do not represent the ray diagram in this manner. The simple reason is that what is the simple reason behind this? The simple reason behind this is that we want to avoid from the difficulty of ray diagram. We just have a one rule which says that when a ray of light is parallel to principal axis, it passes through focus. We generally state like this. So dear students, I have mentioned this lecture in English, and I want to know your feedback whether I will use English or I will use English as well as Hindi. Please write in the comment box. Thank you very much for watching. If you like this video, then like, share and comment. Thank you very much for watching. In the next lecture, I will be live and try to explain all these terms. Today I have tried to live, but due to technical error, I was unable to do so. So dear students, next time I will definitely try to live, and today I have also opened your live chat option. So don't worry, next time I will be live. Thank you very much for watching.